Coming up on This Week in Radio Tech, Peter Femal is here. He's talking about redundancy. See what I did there? But in more ways than you'd normally think about. Redundancy in audio over IP and lots of other systems too. It's all coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support online at bgs.cc. By the Ruby console from Lavo. See Lavo in your future at lavo.com/TWiRT. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by the CalRec Type R console system. Type R is a brand new, modular, expandable IP-based radio system from CalRec Audio. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to the light bulb at the top of the tower. You know, for about 5 or 6 years now, I've been saying I'm going to get my beacon back in here. Maybe I get Peter to come to Nashville and help me fix my beacon so I can put it here in the studio. I'm Kirk Harnack, your host. I work for the folks at the Telos Alliance, and we're doing the show today. I am in the Telos Alliance studio in Nashville, Tennessee. And as always, I appreciate my friends at the Telos Alliance, my longtime, nearly 19-year employer, and just great people who make incredible gear. So that's my blurb for the Telos Alliance. I really appreciate them affording me a little bit of time each week to do the show and have great guests on where we get to learn about all kinds of technology, some that the Telos Alliance is involved with and some not, but all of it having to do with broadcasting and broadcast engineering. That's what the show's all about this week in Radio Tech. Well, Chris Tobin can't be with us today. Last minute, there was a water main break, apparently, in front of the building in Newark, New Jersey, where WBGO FM radio is. And that's where Chris, holds court and conducts things and keeps them running. He's the director of engineering there at WBGO. And so he's having to bail out water or snorkel or something like that in the basement of the building where WBGO is. I'm sure we're going to get to hear about it in a couple of weeks on the show. And we'll have some debriefing about all that and some look back at maybe, what could be done differently, or was it all done as well as it could be? I don't even know if they're on the air or not. So anyway, good luck, Chris. Take that snorkel with you and be safe. All right, our guest today, we do have a guest, and I'm so delighted to have him on the show. I think I got to spend an Uber ride some years ago with Peter Femal from the Chicago area. Peter, welcome in to This Week in Radio Tech.
How are you? Thank you.
I'm good. It's good. It's good to see you. Tell me about your company. You've got the company that does engineering called Public Media Engineering. What's that about?
So it's Public Media Engineering, or PME. We're an engineering and integration services company. So we do maintenance for radio and TV stations to turnkey installations. So it's kind of multifaceted in that regards. So from transmitter to studio to IT services, that's the nature of our business. So.
It sounds like you do what I used to do, except you probably do it a lot more professionally and with much newer gear. I was a contract engineer in the early to mid 80s and the late 80s and a little bit in the 90s. I still do a bit of engineering for my own radio stations in Mississippi, Hawaii, and American Samoa. But I got to tell you, the feedback I hear from your customers and the pictures that I see of your work, wow, just amazing. You are just really top notch.
Thank you so much. Yeah, I mean, we try to do the best quality. We want the final product to look like when you used to get a Harris transmitter or a Continental and you opened it up and everything was bundled and beautiful and documented. That's the final product we want. So yeah.
Oh, that is so awesome. That is so awesome. In my years of engineering, speaking of transmitters, and we're going to actually talk about transmitters today. We'll set up our topic here in just a minute. But my goal was, I never considered myself to be a really bright engineer, but I knew if things looked right, and if they looked right, they usually worked right. And so whenever there was an issue with a transmitter or an audio console, anything that seemed to have some wiring in it and parts, my goal was always to return it to its factory new condition. In other words, make it like it was the day it left the factory. Now I know some products get updates out there, right? If you've had a Harris or an Autel transmitter, you've probably received some updates or some offers for, hey, we found that this Zener diode is not the right one. Be sure you put this in. But my goal was always to make things like they were the day that it left the factory. Do you have any kind of the same outlook on that?
That's very similar. So actually, the side is putting a new tube and retuning an HT transmitter. So trying to get it back to how it works on the factory floor is ideal. So I agree.
Now, when you're building new studios, that's of course, then you're the factory there. So that's why you do that good looking work. Hey, we're going to be talking about one of your favorite topics, and that is redundancy. And Chris Tobin and I have talked about redundancy a few times, and how it's important to have backup systems and things like that. But we're not going to just cover old ground here. We're going to cover some new ground. And what I find particularly interesting, and I have preached this, although I haven't worked at a station that can afford to practice it. And so I'm curious, Peter, to hear what you have to say about redundancy in audio over IP systems, because that's what you've been focused on lately. And hey, we're going to take a quick break here from a couple of the companies that help make this show very possible. And then we're going to be back with Peter Femal here in just a few minutes. So hang on. We're going to hear from our friends at CalRec. Be right back.
CalRec's Type R is a modular, expandable IP-based radio system featuring 3 slimline panels, a fader panel, a large soft panel, and a small soft panel easily configured to give the operator full control. Layouts are saved and recalled quickly between shows. A single 2RU core with integrated I/O gets customers up and running fast, and that single core can power up to 3 independent mixing environments with no sharing of DSP resources. Available in 4 DSP packs, and as your station grows, larger packs can be added, enabling it to grow with you. Power to the surface is supplied via standard PoE switches, keeping cabling to a minimum. Type R is fully AES67 compatible, as defined by SMPTE 2110, which means that it is also compliant with NMOS discovery and connection management specs. All these features combined make Type R the most flexible radio console you can buy. Find out more at calrec.com/TWiRT.
And be sure you go there and add the /TWiRT at calrec.com/TWiRT. Really appreciate that. Oh, my goodness, look at this. Angry Audio. They bring our program in part. Studio guests are really only human, and humans have a tendency to cough and sniff and clear their throats, even on the air. Every guest needs one of these gizmos. It's the guest gizmo. You know what else guests need? They need headphones, which is why each guest gizmo has a studio quality headphone amp with individual volume control. Anything else? Well, you've seen those mic arms with the built-in LED tallies. They're beautiful, but how do you get the light to light up? Well, the guest gizmo does that too. Turns on the red light whenever the mic is hot. And installing the guest gizmo in your studio furniture couldn't be easier. You just need a 2 3/4 hole saw and a steady hand. No router required. Your studio gets a clean custom appearance, and you get all the credit. So check out the guest gizmo and all the other cool gadgets at angryaudio.com. angryaudio.com. Thanks a lot, Angry Audio and CalRec, for sponsoring this week in Radio Tech. And hey, I want to chat for just a second about this Angry Audio stuff. Peter, you might want to try some of this stuff out from Angry Audio. They have that guest gizmo is just amazing. You probably have your own solutions, but it's pretty cool what it does. And I love, you just drill a round hole with a hole saw, pop it in, and it looks like you're an expert carpenter.
Right. Yeah. I mean, we've installed, the Telus panels. It takes a little more precision than just a single hole saw, but that would be nice just to pop that in and away you go. So I'll definitely.
Hey, so tell you what, we have this. Our audio from you is a little bit shaky, and so it's great when you speak up well and I be quiet. So now that doesn't mean you have to talk for 20 minutes, but at least you can talk to your heart's content when you do talk a bit. You've been doing a lot of build outs of new studios that are equipped with audio over IP. And Peter, I understand you have experience with Axia Livewire, with Wheatstone's Wheatnet, and I'm going to guess maybe another 1 or 2 things as well, probably some AES67. We're going to get to talking about redundancy, but if you would, give us your initial thoughts about this whole world of AOIP, and then we'll start talking about redundancy after we just kind of hear your comments on AOIP and new studios.
Yeah, so we've done, from WheatNet to LiveWire to Dante, any of the current standards we've installed it. Our big thing that we try to do is mix old school with new school. So basically with the thought that if I'm the director of engineering or chief engineer for a radio station that we're working for, and it's Thanksgiving Day, and something catastrophic happens on the audio over IP system, that engineer can do a bypass and continue having Thanksgiving dinner with their family and deal with the issue later. So the way we look at doing redundancy is making sure that we, on some products where you have dual network interfaces, we have separate cores. We are able to drive those nodes or other I/O devices with power over Ethernet. And then from that, we have redundant power that is feeding those network switches and those nodes or blades or whatever device we're installing. Then in the final product, we'd like to have a way to allow an engineer or customer to bypass the entire audio over IP system if need be, and then they can do maintenance on it, do firmware updates on it, or they can physically replace it in the future when that time comes, and stay on the air without any interruption to audios of listeners. So.
Peter, my first introduction to an enormous level of redundancy in an AOIP system was actually quite a few years ago when Radio Free Europe and Radio Liberty, they're combined together in Prague, Czech Republic. They moved to a new facility. They had been in a building that I think was previously like an American embassy building, or anyway, it was apparently full of Russian bugs in the walls. And there was across the street, there was like this microwave tower that was, beaming microwave energy to the bugs, and then they were sending the audio back or something. But anyway, they moved out of there. They moved to a brand new building. It's like a fortress. And so the folks at Radio Liberty, Radio Free Europe, they wanted a completely redundant system without having to buy two of absolutely everything. And so I think they had, at the time they built this, they had about 50 studios. Now they have more than that. But they did it. And I'm going to ask you to expound on this or maybe tell me what things are different now. But they did it by using a topology where they had a core Ethernet switch in the middle. And it was a big one, like a Cisco 6500 series. And then out near a couple of studios, they'd have what we would call an edge switch, an Ethernet switch that was serving in an edge capacity. And that edge switch had basically two uplinks back to the core switch. Or actually, it had one uplink to one core switch and it had another uplink to another core switch on a different floor. So they actually had two core switches, and each studio or each two studios had an edge switch, and each edge switch would feed streams and receive streams from to and from two different core switches in different parts of the building. Okay. Now, the studios themselves weren't duplicated, although if they had to, if this studio was out of commission, they could move to a show to another one. They had that kind of redundancy. But they had actually packet by packet redundancy in all of their streams, because every stream went to two different core switches. And then they had to figure out, Peter, how are we going to make it seamless, packet by packet, automatic, that each node that was receiving streams from somewhere else in the building would not like double up on its packets. Would only process one packet from a stream. And they did that in the core switch by artificially, in software, adding an extra hop, changing the metric for the number of hops. And so the end devices would ignore the ones that had more hops. And if the main core switch went away, then the one with more hops would be the only one left. And so it would grab those packets and use them. Now, I may be oversimplifying that. I'm not sure. But what they ended up with was an extraordinary, a whole floor could catch on fire or power go out or something catastrophic had happened, and they'd still be on the air from a bunch of their studios. Tell me about, well, give me your comment on that, and tell me about what kind of things you guys do now to achieve AOIP redundancy.
So I think that's a great thing. I guess I'd be curious to see how they implemented that. One thing that we're looking to do in some current installations is two separate, like you're saying, 65, 6300 Cisco series cores. And those cores, core 1 and core 2, are then driving network interface 1 and 2 of the X node, specifically. So you could lose one whole core and the whole system would continue to operate. So that's currently one of the topologies that we're looking at and implementing. So
you earlier mentioned, and this show, This Week in Radio Tech, we typically don't make it about a one particular brand of product, but I think both of us are pretty familiar with the Axia X nodes. And you were telling me earlier that one thing that you like is the fact that they have two network interfaces, and you can use these in a variety of ways. At my radio stations, for example, I don't have two cores, so I just use one network interface to feed my core switch. And I happen to have the nodes that don't have internal power supplies. We made a few of those, and I saved a few bucks and bought the ones that you have to power externally. So anyway, so I use the other port for power, right? But you can use it for management, but you can also use it for duplicate streams. Is that something that you guys have been playing with?
Yeah, that's definitely what we're working with. In a very simplistic model, let's say you have a studio that has a power station, and you have a TOC where an X node is living, and you have devices in the TOC, and those devices are feeding that X node, and they're mission critical to that Studio X that currently has the power station. Well, there's been installations where that X node is being driven by a Cisco core switch in the TOC, and then the second network interface is actually connected back to the power station in the control room across trunk cabling that's installed. So if you happen to lose the switch in the TOC, the system keeps running off of the power station, in the studio. So that's one kind of basic way of doing it. You don't have the crazy money to do a 6500 series, stacked set of Cisco switches or something like that. It's kind of one way to look at it.
That sounds pretty doable. At my little radio stations, well, I'll give you an example. I have a couple of stations out in American Samoa, and that's a long drive. It's a lot of flying to get out there. And the equipment there is fairly new. We've got some new consoles. They happen to be the little Radius consoles from Axia. We've got some older nodes, the original silver face nodes, and we've got a couple of the newer X nodes there as well. But for Ethernet switches, I'm kind of Mr. Cheap. And so for Ethernet switches, for my radio stations, I'm not suggesting anybody else do this. This is comfortable for me. I go on eBay and buy used Cisco Ethernet switches. They're typically, off lease or whatever, and they're typically not horribly old, 3, 4, 5 years old maybe. And you'll buy them for literally pennies on the dollar. And I'll get a good honking switch, maybe even a 3560 series switch. But I'll buy two of them, right? And so I'll configure them both the same, or actually I'll have somebody in the tech support department at Axia just, remote in and do it much more quickly than I can. And then I'll just mount them both in the rack. So they're in the rack in American Samoa, there's these two Ethernet switches. They're identical, but one of them has no power and nothing hooked up to it. And so if they ever determine that the switch died, they're just going to unplug the one. And I tried this, but before I left there, after I built the studios, just moved everything over, and it worked fine. They were off the air for a few minutes while all that happened, and the thing booted up. But at least they weren't off the air for 4 days while we ship another one to them. So, just spent $200 on each switch instead of $2,000 on each switch, and we have full redundancy. For a small station, is that kind of a reasonable plan if they can stand to be off the air for 10 minutes?
Yeah, that's reasonable. Otherwise, what another option would be is if you had, I don't know, a Core 32 or something like that in the studio or a power station. Could drive program, even across the set of trunk cables to the TOC, and with the idea in mind of having a final switcher that prior to one of your STL chains. So maybe your main STL chain, you have just a standard analog or AES audio switcher, and then you're getting program audio directly from that studio. So you just switch to input B, or you can do something fancy, have it automatically switch over. You can have a Burke system switch over to it. You could have Pathfinder do it. There's a million different ways to do that sort of thing. Or you can physically have a human push, input number 2. And then if you did have that circumstance like you did, they would be on driving from program audio from the studio.
And you know what? I didn't wire that up, and I should have. May have run out of time. But what you just described was actually the very first real redundancy on multiple studios that I had ever heard of. And this had to be, my goodness, over 15 years ago. It was the installation at WOR in New York, where Tom Ray was the engineer, and he wanted some kind of backup. Most of their programming was produced in each studio, right? They didn't have a lot of centralized equipment. They did have some phone systems and codecs, but they were mic live a lot. So, in other words, a studio could stand alone. And so Tom Ray did exactly that. He put the studio engines, out in each studio. They were, they weren't fanless, but they were quiet enough. Anyway, yeah, he did that. He took an analog output from a node and ran that back to master control, where they could patch it on the air if the whole AOIP system died. Yeah, it's a worthwhile thing to do, isn't it?
Yeah, I mean, we've done installations of Wheatnet infrastructure, blades and nodes and TV stations too, where they did physically want it brought out on a patch also, so that somebody in master control could patch around if something happened. So I've seen what you're discussing there too. It's not as automatic as having a switcher in place, So, but anyways,
yeah. So, what in your experience here with AOIP systems, what part of an AOIP system tends to be the most fragile, or the most maybe a good word is brittle? In other words, what is like, okay, if you mess with this, you're going to go off the air. Don't mess with this. Do you have any thoughts about that? Anything to keep you up at night, or you worry about?
I think a common thing as the industry moves to audio over IP is, back in the I don't know, 10 years ago or a couple decades ago, you had a lot of DAs, right? So you'd walk into a TOC and there'd be rows and rows of distribution amplifiers. Now, most stations did not care about having redundant power or a UPS for distribution amplifiers, right? So if the power went out shortly, either the generator came on and they came back on, or just interruption basically. Now, as we move into audio over IP, everybody's installing UPS battery backup systems. Well, what is the one thing that ends up happening? Well, the batteries go bad, or I think almost probably every engineer that is watching this show has had an APC system do a self-test and dump the whole load and never come back. So the big thing that we push there and we try to install is having ATS switches in place. So those ATS switches will either have a second UPS driving them, or have just utility power. So if you lose your UPS, you're not completely off the air. And I think that's
now you're using a term that I'm not familiar with, and that's an ATS switch. I'm sorry. Tell me about what that is.
So automatic transfer switch. So
okay.
Multiple manufacturers make it. I will say we found a very good one from Eaton that works very well. We've also installed APC ones, and they've worked very poorly. But there's some older CCs that work good, but the new ones did not work so good. The Eaton ones we've had really good success with. So.
I've had good success. Somehow, it seems like I never get to specify what UPSs go into my radio stations. They ended up getting traded out, or who knows what. And yeah, I too, and I hate to say anything bad about anybody, but man, I've had the worst luck with APC battery backups, and I know other people have too. And we've somehow in a trade for like we bought a translator from somebody, I don't know, and we got this Eaton backup. I swear, 8 years later, it still works great. And like, do you need batteries? No, I'm fine. It just works terrific. So that's good. I'll put a link to Eaton automatic transfer switches in the show notes. So yeah, I agree with you. Yeah, and in fact, it's probably as much as anything else in my experience in the last 10, 15 years, it's been UPS systems that have knocked us off the air as much as any actual broadcast gear.
Yep. And a simple way around that too is as people are building their Axia, systems and their TOC, most of the Cisco switches, you can get dual power supplies. You can drive those from separate UPSs. That would be if you don't want to put the ATS switch in, that's one way to do it also. But yeah, I do love the Eaton products, those dual conversion UPSs, like you probably had at that station, that translator you bought. One big negative is they have fan noise, so you want to keep those out of the studios. So some people would prefer they keep them out of the studio. Some people will put them in the studio. But if you have a Neumann microphone in the studio, you'll hear that fan all day long. So.
Yes. Exactly. You sure will. Let's see. I was going to ask you about something else. Oh yeah. Sometimes we have the opportunity to buy equipment that has either options for or comes with dual power supplies. You just mentioned Cisco switches with dual power supplies, and I guess you're going to say absolutely yes. In your view, it's always good to have dual power supplies if you can get them.
Yes. Oh, most definitely. And in a big facility, maybe you should have one on the shelf. But like you had said too, I have seen on Amazon or eBay or whatever, there will be manufacturers selling power supply that were open box or whatever. And if a station is concerned about spending $900 on a spare power supply, there's cheaper ways of acquiring a redundant supply if they have to. So.
And the follow-up to that is, indeed, if you have dual power supplies, don't plug them both into the same power strip. Plug them into different things. One could be just commercial power, and the other could be, to your generator feed or your UPS feed. Or as you mentioned, if you've got dual UPS feeds, even better then, and then you'll have that power all the time. And same thing for things like obviously, if you got some servers in your station, then this is a topic that I've been kind of hot on for the last couple of years. Not that I know a lot about it. I know enough to know that this is a good thing. When we built our stations in Mississippi, we had to do it cheaply, and we bought a bunch of off-lease Dell desktop PCs to run Rivendell on. And they worked fine for a couple of years, but when they were 2 years old, to us, they were probably a grand total of 6 years old. And things like fans and power supplies and hard drives, started failing. And every time one did, we had a station off the air until we could rebuild something else, or at least move an image to something else. And more recently, about a year and a half ago, we started moving to servers. Now they're still off lease servers, so they're used, but they're new to us. And dual power supplies, fully rated hard drives, dual Xeon processors. I'm not sure if there's failover for that or not, but the things that tend to die, and lots of fans. I mean, like 17 fans inside one of these boxes. So several things can fail, and you're still on the air, and you get warned that there's something wrong. So for us, we've been using these Dell servers, and hey, I'm sorry, I'm a small market guy. The whole idea of using servers was new to me a year and a half ago, and we started doing virtual machines with the KVM hypervisor, and now we've got a couple of totally backed up servers running about 4 instances of Rivendell, plus a couple instances of Windows to do some various things, and we're really happy with that. We haven't had failures now in over a year since we put those things in. I feel really good about the hardware, at least for a while longer, and the fact that I have 2 of them for fairly cheap works out nicely. Does that sound to you like something reasonable for small market?
Yeah, that's definitely reasonable. In the bigger markets, if you look at like what WideOpen's doing, they're putting in 2 servers with Everrun and running VMs and all that stuff also. So, that's pretty standard. That's standard practice moving forward. So, yeah, I think you got a good system.
And you know what? I think in the next week or two, we're going to have a guest on the air. In fact, I think it's next week. We got a guest on the air. Oh yeah, it is Kevin Bunty. He's a small market engineer, but Kevin's been doing a lot of virtualization. And I guess the benefit is you end up using more expensive hardware. It's better hardware than the desktop PCs that we've been used to putting automation systems in, or what they may have come on. And so you do have the dual power supplies and lots of fans and fully rated environments for hard drive or even SSDs. And so you're just, yes, you have more eggs in that basket. So you get 2 baskets, and the baskets are a lot better than the baskets that we used all through the 90s and early 2000s, don't you think?
Oh, most definitely. Yeah. I mean, think about back in the day when you had SCSI drives and like the AV100 systems. So it's a lot has changed. So yeah, it's great.
So we're going to take a quick break, and when we come back, we're going to see what final thoughts that Peter has about redundancy in audio over IP systems and some of the benefits of being able to work on them remotely. I mean, I've sung the praises of these before, but I want to hear what what Peter has to say. And then we're going to talk about redundancy in some other more traditional systems around the broadcast plant, because this is what Peter and his company, Public Media Engineering, is all about, is being able to build something that sits there and runs. And in case something goes wrong, you got a backup, and the backup works. So we're gonna hear about that. Hey, our show, This Week in Radio Tech, is brought to you in part by our friends at Broadcasters General Store and Innovonics. We'll be right back.
The Aaron 655 is the latest addition to the Innovonics family of rebroadcast receivers, designed specifically for FM broadcast translators, also referred to as relay transmitters. The Aaron 655 is unique as an uncompromising DSP-based HD radio and FM receiver combined with a powerful 3-band audio processor and dynamic RDS encoder. IP connectivity adds streaming capabilities, and a web browser interface gives you total remote control of the unit from any PC or mobile device. The Aaron 655 gives you maximum flexibility for program sources. Select program audio from analog FM, digital channels HD1 through 8, streaming sources, and analog or AES digital line inputs, all with assignable failover audio backup. The internal RDS encoder allows you to customize your RDS messaging. You can use incoming off-air RDS data, convert HD radio pad data to RDS, convert streamed metadata to RDS, or receive IP telnet data. Comprehensive audio processing includes gated and windowed AGC, a unique syllabic leveler, 3 bands of compression, and both wideband and independent HF limiting. Easy setup is achieved by using 10 factory presets and 10 customizable presets. The processor also supports day parting, allowing automatic preset changes to follow different programming formats throughout your broadcast day. The front panel has an OLED display and jog wheel with intuitive menus for easy setup, advanced control, and editing for all operating parameters. The Aaron 655 dynamic web interface gives you total remote control of the unit from any PC or mobile device. A comprehensive set of menus includes a quick overview of now playing info, input-output control, processor options, RDS encoder, alarms and notifications, SNMP settings, and much more. You can also listen to the live audio broadcast streamed through the web interface.
Check out this Innovonics Aaron 655, a really amazing box. And you can get yours from Broadcasters General Store. You can find them on the web at bgs.cc. You can call them, like I do, because they're really friendly, at 352-622-7700. 352-622-7700. Awesome dealer. They will really take care of you. Appreciate their sponsorship, too, of This Week in Radio Tech. All right. Hey, Peter, before we move on to some other redundancies, anything else about AOIP? And I'll just preface it by saying, working for the Telos Alliance and Axia, I imagined and I, sung the praises of being able to remotely fix things and do things because a system is based in audio over IP. It's a network. I got to tell you, I put that capability to use every week. I mean, there's something goes wrong. Usually somebody pushes a wrong button. Somebody did something stupid at my radio stations, and I just remote in and, here's your problem. Click. There you go. Everything's going to be fine now. Whether it's that or whether it's adjusting mic processing remotely or even on-air audio processing remotely, audio over IP, everything on the network just makes that so terrific. You're probably going to agree, but maybe you've got some better examples too.
No, I definitely agree. I mean, the world of engineering has changed. I mean, we use LogMeIn and LogMeIn nonstop all day long. Having access to every client's system, router, transmitter, whatever, we can get access to it over LogMeIn. And obviously, there's tons of different products out there for that same purpose. But with audio over IP, depending on what system you have, you can definitely route around any sort of audio issue. Even going back to like a TDM-based system, you can also route around things. So having a web interface, and you can log into like an SAS router control software, a WheatNet navigator, or a LiveWire system, and route around the issue that may be present. Or a lot of times it's operator error, where maybe the board op DJ just loaded the wrong profile or has something busted improperly. Having that functionality definitely helps the engineer, so the engineer doesn't have to drive it. There's still tons of legacy systems out there running analog consoles, and yes, they're still running and they're running just fine, but you do not have that remote administration that you can get with audio over IP, which is a great feature.
It sure is. Hey, I want to ask you quick about your preference for remote access. I know a lot of folks use TeamViewer. A few people pay for it. A lot of folks, use it for free, whether or not they should be. I know a lot of folks were on LogMeIn for years, and then it seems like they had some changes that kind of turned people off. But you like it. You're still using LogMeIn. That's your favorite one?
Well, I mean, I think we have a pretty heavy install base of it, so there's probably 4 users on it right now. So unfortunately, we're just kind of stuck in it, But we have looked at other things, and we may make a change at some point in the future.
Gotcha. Hey, so we've been talking about audio over IP redundancy and some ways to achieve that. And some of it involves just, hey, run a wire, run that backup audio from the studio to some central area where you can at least patch it in through, a traditional backup switch or, some kind of broadcast tools things or relay, what have you. I don't happen to have that in most of my stations, but we do tend to have backup Ethernet switches that people could move to. But now we're going to move over to some other types of redundancy. Peter, I know you had some thoughts about a station will have a transmitter. They'll have it for decades, really, and they'll get a new transmitter, and they'll keep the old transmitter as a backup, right? They'll have just enough plumbing around where either they can push a button and switch it, or maybe they have to use a wrench and, undo something and move a cable, move a big coax or a pipe over to the old transmitter. And you're saying that this plan doesn't always work out too well because not everybody tests the backup, which worked for decades but may not work today. What are your thoughts about that?
No, that's one of my big pet peeves is testing your backups. Whether it's in your audio plant or whether it's in your transmitter plant, test your backup and make sure it works. I can't tell you how many times we've gone to a station under contract and we walk through the facility and it's like, well, that's our backup transmitter, which was the old main transmitter, which is now 30 years old. Well, do we know if it works? When's the last time it's been tested? And then lo and behold, you turn it on, test it, and the exciter doesn't work or something like that. So it's not a backup if you don't trust it to run for multiple days and not have issues. So
that I'm writing that down. It's not a backup if you don't trust it. I like that. It's not a backup. That's gonna, you know what? That may be the title of the show. It's not a backup if you don't trust it. Antennas, coax, combiners, switches. Talk to me about some of the techniques that are used nowadays to good effect so stations can have backup post-transmitter.
So I mean, a lot of stations utilize a main and auxiliary antenna. You'll see that from the largest market to the smallest market. I got my start in Appleton, Green Bay at Woodward Radio, and we had and Steve Brown up there, did a really good job of having backups and backup antenna systems. In the major markets, you're seeing, places that have a main and auxiliary antenna, and then even auxiliary transmitter sites that are off-site, just in case something catastrophic happens to the main site. There is even discussions, and I have seen it, where people have a main combiner and a backup combiner. You do see that, but otherwise the typical coax switch, that's very common and installed and used in most operations. So for backups,
One of the notions that has been passed around a bit is the idea that sometime down the road it might be possible to have your broadcast infrastructure at a data center, maybe one that the broadcaster owns, or in somebody else's data center, a cloud-based data center. And well, in that case, backup kind of becomes somebody else's worry. I mean, yeah, it's your worry because it's your radio station. But somebody else's infrastructure becomes your backup. And I guess the point that I was leading to is one way to do backup is for not a lot of money. And I mean like under $20 a month, I believe. You can basically rent a little web-based automation system in the cloud. And you could load a bunch of your playlist up there. Now, this is not for public consumption. You're not putting this out there as your streaming radio station. You just are kind of duplicating part of your format, enough for backup up in the cloud. And then at your transmitter site, you have, whether it's a hardware device or a server, or whether it's just a desktop PC, some device that can stream that audio if necessary and keep you on the air that way. That could be one way. I mean, if your whole studio building was part of a fire, heaven forbid, or explosion or something that kept you from going in the building, then, what are you going to do? Well, what if you had everything or had enough backed up in the cloud to where you could at least provide programming, your call letters, get some ads, put up there and do that. Am I just way crazy, or is this, one cheap way to make sure your programming can stay on?
That's a great idea. Typically there you'd see a barracks box, or with like a Nautel. A Nautel can pull down a web stream and put that to air, as a bill. You'll see it's very common in major markets to have a backup automation system out at the transmitter site that has basically music library commercials. So for stations that don't have that, we've gone as far as, depending on, their operation and their desire to do it, we'll put in a small PC with a solid state drive and radio DJ running, which is that free automation software. So in a, all out, disaster, they still have some sort of audio on the air, is the idea there. So.
What you just mentioned is actually simpler. It may cost, it's more capital cost, but yeah, put a backup automation system at the transmitter site. Most radio stations, if they want, they can have IP connectivity to the transmitter site, even in small markets. Every one of my transmitter sites, and believe me, rural Mississippi is pretty rural. We've got IP at each transmitter site available. Not all of it's fast. Some of it's on the order of 6 megabits up and down, but we've got it out there. So yeah, we could put backup automation systems at each transmitter site and be able to switch over to that either automatically or manually. That's a good idea. Good idea. How about, we do think about generators, and we've talked about generators on the show before, but talk to me your best practices for making sure your backup generator, power generator, is adequate and tested properly.
Well, just basically making sure the generator does a weekly self-test, and then have it hooked up to a BERC system or whatever your remote control may be, a Davicom, whatever, Automat. and have it actually tell you that it's completing a self-test weekly. And then as an engineer, go out there and actually run it. Self-test it yourself. We have sites where we'll drop the load and make sure that the facility runs. Just basically do a fake power outage. And that happens, out in a rural transmitter site to even a big facility like the John Hancock Center, where there actually is what we call Big Bang, and we test the generator and make sure that all stations can operate and be powered by it.
What are some of the things? Okay, so a generator can do a weekly self-test, and I've had them do that as well. But I've also heard, horror stories of the automatic transfer switch failing in some way. And even on Facebook, in one of the broadcast engineering groups, there's been a lot of chatter about a neutral cable coming loose or breaking, and therefore the voltages being all over the place inside the transmitter building and destroying gear. Do you have a checklist or just some ideas of things that an engineer should actually really check over, even if it's as little as annually?
Yeah, verify that basically when that generator runs that it is, outputting the proper power at the proper voltage and frequency that you need. So that's definitely an issue. A lot of stations have a power conditioner installed or a UPS system that will also, mitigate that issue. We have had it where a generator, basically like you're saying, went crazy and would not supply the power in a system-wide Eaton UPS, basically did not accept power from that and would not transfer load back. So, it's really, with a generator, there's a lot of people who want to do maintenance themselves, and they'll go out there and, change the oil and replace the filter and do that, themselves to save the station money. But there's still nothing better than having, somebody from the manufacturer come out and do a preventative maintenance once a year on that generator. It should be kind of standard.
You mentioned something that I think is critical. I've come across this myself and gotten burned by it, and that is, will your UPS accept the generator's power as being good enough to charge the battery, to switch back to commercial power, or is it going to keep on chewing up its own batteries? And in my case, it was generator power coming from a portable generator that wasn't good enough. Now, I would hope that an installed generator would produce good enough sine wave power at the right frequency. But you got to check that, don't you?
Yeah, and there's a very common issue I've seen at a bunch of sites is APC. I don't know the newest one. It's the one with the LCD display, but you can basically adjust the power quality that the UPS should be seeing, which basically adjusts the efficiency of that UPS too. But there's like an excellent and a good and a poor. But in that circumstance, you're going to want to have that UPS set to that poor quality or the good quality, not the excellent, because So we've had sites that are rural and the power quality is not excellent out there. So you just got to make sure that you see that feature and read the book and read the manual and know that what you're installing and how to set it up. So
my last direct experience with that was literally 20 years ago, but we had a bunch of little APC UPSs, and it turned out, and we found this out after the batteries ran out. Hey, wait, the generator's running. Well, how can we have no power? They on these older ones, they just had a little dip switch, and for accepting a wider input range of power quality, and boom, hit that dip switch, and all of a sudden it says, "Okay, I'm happy now." I can't feature why they would make UPSs that were so finicky about that. Well, I guess if you're getting what they considers cruddy power in, then it doesn't want to pass that on. So I guess that does make sense, but better than being off the air. Wow. All right. Hey, we're going to have a tip of the week from Peter in just a few minutes. We're talking on This Week in Radio Tech about redundancy. We covered audio over IP redundancy, some techniques to make those systems more reliable and redundant. And also be sure you check out your backups, whether it's a transmitter or an antenna. whatever it may be, you've got to check it because if as Peter said, let's see, you said it here, it's not a backup if you don't trust it. So that's really good. We're going to take our last break here to hear from our friends at Lavo, and when we come back, I'll have a tip and Peter will have a tip. So hang on, we'll be right back.
There has probably never been a better time in history to buy a new radio mixing console. Today's consoles are more sophisticated than ever, with more features and functions than you can shake a stick at. But have you noticed how complicated they are? There's a sea of knobs and switches and displays and buttons. Some of them look like you might need a pilot's license to do your show. Well, a board doesn't have to be complicated to be powerful. Just look at the new Ruby mixing surface from Lavo. The first thing you notice is how smooth and streamlined it is. Ruby has lots of cool tech, but what it doesn't have is that confusing ocean of buttons that clutter things up. Now, we all know that there are some console features the jock only uses once in a while, so why dedicate controls to them? Ruby fixes this problem by moving those once-in-a-blue-moon controls to a touch-sensitive, customizable GUI that happily shares screen space with your other studio software, helping you fight control room clutter. Thanks to this design innovation, talent that use Ruby produce smoother shows with less errors. Controls that are used the most fall naturally to hand, while functions that rarely need adjustment are easily controlled with just a couple of clicks in the context-sensitive GUI. And Ruby has cool features you won't find on other boards, like Auto Mix, an intelligent gain writing function that guarantees the perfect mix for multi-mic morning shows and call-in segments. Dual mode snapshots that instantly switch the motorized faders between on-air and production modes, and enough DSP and I/O options to make even your pro sound pals green with envy. And because quality is as important to Lavo as it is to you, every console is proudly built to fanatically precise standards at Lavo's own factory in Germany. If you're ready to declutter your control room, do yourself a favor. Check out the new Ruby and the other cool Lavo radio tech at www.lawo.com/TWiRT.
Thanks a lot, Lavo, for sponsoring This Week in Radio Tech. And do go to that website, add the /TWiRT on there. It'll take you right to the radio products, and it'll let them know at Lavo that you heard about it here. Really appreciate that. All right, it's Kirk Harnack along with Peter Femal. We are on This Week in Radio Tech. As we mentioned at the top of the show, Chris Tobin is underwater. He's got his snorkel on. They had a water main break, and he's in the basement of WBGO trying to siphon out some water right now. So I wish Chris very well. All right, it's time for our tips of the week, and because I'm really old and forgetful, I'm going to go first. And then Peter's going to have a tip of the week, probably better than mine. My tip is a little bit self-serving, but I got to tell you, one of the things that I enjoy in life, I enjoy listening to podcasts, especially short ones. I realize ours is an hour long, but I've been using YouTube for this for quite a while, and I really like YouTube because I pay that extra money for YouTube Premium. That means that I don't have to keep YouTube up as the in the foreground of my phone. I can do other things and it'll still play. Now, they don't do that if you don't pay for it. Also, I never see an ad on YouTube anymore at all. Never. So that's a blessing. And I can subscribe to things, and I'll get a few things I really care about. I'll get a notification that, hey, so-and-so has a new video. Well, This Week in Radio Tech, our permanent home for our finished shows is on YouTube. You can go to YouTube, look for This Week in Radio Tech or TWiRT, and you can find us. Subscribe to the channel. That's my tip. Please subscribe to our channel. That'll make the subscriber count go up. It'll also make us come up in your YouTube recommendations when you're looking for something to watch. Hey, we'll be there. We'll remind you that we're there. You could even hit the little bell and be reminded that there's a new show for you to listen to or watch. And of course, as I mentioned, you can listen to it as well. You don't have to watch it. If you're going to be a subscriber to the YouTube channel, then here's what's coming up in the next few weeks. Some of the things that Peter and I were talking about. Kevin Bunty will be on next week talking about server virtualization technology, even in small markets. And Kevin's in a small market. The week after that, Mike Porter is going to be with us. Actually, we're going to be at the Quonset Hut studio. That's often called RCA Studio B here in Nashville, Tennessee, where a lot of famous records have been recorded. So we're going to be looking at the recording gear there. And then a couple weeks after that, We're going to have a fun show. A guy named Ken Herron is going to be with us. Ken is a drone expert, and he's a radio guy. Yeah, he works at a small radio station in West Tennessee, and but he travels all around doing beautiful drone photography, and he's got his own podcast. So Ken will be with us here in about a month from now. So those are my tips. Subscribe to our YouTube channel. You will be blessed for it. All right, Peter, tell me what you got. What should we know about to make our lives better?
I guess my tip is kind of goes back and says testing your backups, and also testing and making sure that your remote user interfaces are working. So whether that's log me in, whether that's a computer transfer site, whether that's the web interface on your work system. So testing those systems in some sort of routine manner, because the last thing you want to do is figure out that it's not working the time that you're off the air having issues.
Oh, that's a good point. Yeah. At my stations, once in a while, for good reason, one of our people will change a password and forget to tell everybody about it. And so what if I had to get in there, because we're off the air? Well, that's a good point. Check those things. So as long as you're in doing some maintenance, hey, here are the other interfaces I typically look at. Go look at them. That's kind of what you're saying, right?
Yep. Make sure they're working. Make sure that, the Nautel user interface is actually working. I mean, you never know. Maybe the computer's crashed. Something needs to be rebooted, or you need to update the firmware on it. But the last thing you want to do is figure that out when you're off the air. So
that's a good point. Good point. A couple extra minutes spent could save you a lot of time and trouble later on. Wow, Peter, this hour has flown by. I want to thank you for taking the time to pull off the road and join us. It's been great.
So, yeah.
So this is your company's service van, yeah?
Yeah, it's just a service van, and you can see the nice big steel wall behind us. It's the vehicle I use the most. The other guys don't really like it, but I like it because it has everything in it that I'd ever need. So, but yeah, it works well for me anyways. So.
Awesome. Good deal. Well, Peter, thank you so much for joining us. I know we tried to get together last week, and thanks for taking the extra trouble to get with us this week. We appreciate your hints and thoughts on redundancy especially. And will you be at NAB?
I will. Most definitely.
Oh, good. Okay. Well, I look forward to seeing you there.
Thank you.
That's right. And PREC. Yeah. Good deal. All right. Thanks a lot. Peter Femal's with us, and on This Week in Radio Tech. Peter, don't hang up. We got to get a picture of you. Our show, This Week in Radio Tech, brought to you by some great sponsors, CalRec, and also the folks at Angry Audio at angryaudio.com. And Broadcast General Store and the Inovonics Aaron 655, and also Lavo at lavo.com/TWiRT. I'm Kirk Harnack in the Telos Alliance studio in Nashville, Tennessee. Thanks a lot to Suncast, our producer. All he does just great work to get this thing going every week. And also thanks to Andrew Zarian, the founder of the GFQ Network. We're going to see you next week on This Week in Radio Tech. Bye-bye.